Hi everyone, here I am yet again, another biology video for you, this time on the nitrogen cycle. This is the last video I'll make this side of half term, but please use the half term week next week to catch up with everything. The aim is that by the end of that week you've completed all the work I've given you this week on populations, carbon cycle and nitrogen cycle, and you've completed all those revision tasks, including ideally doing 2 exam papers, a component 1 and a component 2, under exam conditions. Okay, let's get on with the nitrogen cycle anyway. Okay, make sure you've got your notes sheet with you as you watch this. Yesterday you should have got up to the end of this point, or from yesterday's video anyway. We're now going on to the nitrogen cycle. First thing to mention very quickly is this. We need nitrogen. Of course, shouldn't need me to tell you actually. Pause the video and work it out for yourselves. Should add that what I'm looking for is some vital biological molecules that contain nitrogen, so think back to the very first topic we did, C1. Right, shouldn't have been too hard that. You should all recognise this type of compound here, a carbon linked to a carboxylic acid, an amino group, an H and an R group. That of course is an amino acid. We need nitrogen to make amino acids. As proteins are just chains of amino acids, we also need nitrogen to make proteins. Therefore, other main biological molecule that we need nitrogen for is of course the nucleotides, which make up nucleic acids. You can just write nucleic acids on your sheet. Right, so I've been a bit generous there. I'm basically giving you the answers to that bit. Now we're moving on to the nitrogen cycle itself. I've sent you all as an attachment the card that you need for this at this point anyway. Pause my video and watch the first video I've sent you in my email on the nitrogen cycle itself. Right, I've sent you all a copy of this PowerPoint as well. Now, you've hopefully got a good introduction to the nitrogen cycle from that video, but it's probably helpful for me to just quickly go over some crucial points. Now, the main way that nitrogen is cycled is basically nitrate ions in the soil are taken up by plants. Those plants either get eaten by animals or they eventually die anyway, and either way, plants and animals, when they die, they are broken down by decomposers. We've already learnt from yesterday's video that the carbon compounds in there, in animals and plants, are basically used for respiration by these decomposers, and carbon compounds are ultimately broken down to carbon dioxide and released back into the atmosphere. The proteins and amino acids in these organisms, the nitrogen containing compounds, are also broken down by decomposers, but this time they're basically, that actually just says decomposers there, they're broken down into by the ammonium ions by the decomposers. Ammonium ions are then converted by nitrifying bacteria firstly into nitrite ions, then by a different type of nitrifying bacteria into nitrate. The nitrate's taken up by the plant again. So the main way that nitrogen is cycled actually is this. This is how nearly all nitrogen is cycled, with just this part of the cycle. But there are a couple of additional factors. Nitrogen gas in the atmosphere can be converted by what are called nitrogen fixing bacteria. You get some free living in the soil, which can convert nitrogen gas in the atmosphere directly into ammonium, or you get these rhizobium found in root nodules in plants that can also convert nitrogen gas directly into a usable form. This is actually directly, sort of, because they live in the root nodules, the nitrogen compounds are directly taken up by the plants. But if we had that going on, these two things slowly taking nitrogen out of the atmosphere would gradually become depleted in nitrogen, of course, and that's not happening. So there must be something that replaces this nitrogen that's taken out of the atmosphere. And there is. You get in soils, also especially in waterlogged soils, you find these organisms called Pseudomonas, which can convert nitrate ions in the soil into nitrogen gas. So that's it for me talking about the nitrogen cycle. Pause this video now and actually do the exercise on the card. Use this slide from the PowerPoint to help you with it. Okay, hopefully that's the card exercise done. You come back to me. This diagram, of course, shows how nitrogen is cycled nicely in natural systems. Now, as we're now well aware, humans tend to interfere with natural cycles, and we certainly have an impact on this nitrogen cycle. In particular, of course, agriculture does. Now, if you are a farmer, you are, of course, wanting your soils to be as high in nitrate ions as possible in order to promote good plant growth. So you've probably already learned nitrogen gas might make up 78% of the atmosphere. There's huge amounts of it around us, and yet one of the main limiting factors to plant growth and therefore crop yields is the amount of nitrogen that plants can get hold of. One of the main reasons your plants don't grow as quickly as they otherwise would is they don't have enough nitrogen. That's because nitrogen gas in the atmosphere is unusable by plants. They can only take up nitrate ions in the soil. And you know that there isn't a tremendous amount or unlimited amount of nitrate in the soil. Many soils can have quite low amounts of nitrates because all plants are competing for it. It really is a significant limiting factor to plant growth, especially in the summer when other factors are good. If you've got nice warm temperatures, very long days with lots of sunlight, the main reason plants won't grow as fast as they otherwise could is lack of nitrate, actually. So farmers are interested in getting as much nitrate into the soil as they can. Now, one way that they can do that is by promoting these processes. Ammonia being converted to nitrite and then to nitrate. I don't know if you can see that clearly from where I am, but let me come a bit closer. Ammonium ions. This phone's all over the place with its focus. Right, sometimes there's no substitute for just writing things out by hand. Anyway, those are the sort of processes I was referring to. If you want ammonium to be converted to nitrite, obviously a lot of oxygen needs to be present in the soil to get that to happen. So you need a lot of air. You need well aerated soils, and even getting nitrite to nitrate, you've got to add additional oxygen. So you need well aerated soils. How can farmers promote aeration of their soil? Well, this is one way they can do it, by ploughing the soil. Turning it over like that does get a lot of air into the soil. But wait a minute. You don't need me to tell you what ploughing is. You lot are a load of Somerset country bumpkins. You probably go out ploughing the fields every day before breakfast, don't you? Anyway, just in case you didn't know, that's what ploughing looks like, and its main functions are: one, it can help to get rid of weeds, but also it just helps to aerate the soil. Now, for the same reasons I've just mentioned, what farmers don't want is this waterlogging of their soils. This will mean a lack of air in the soil and a lack of nitrification going on. The ammonia won't be converted to nitrates. So how do they prevent this? Well, several ways. One, you've got to make sure you've got a good structure to your soil. Soils usually mostly consist of clay and sand particles, and ideally you want a mixture of both in there. There's also some humus or organic matter in there as well as air and water, but it's mostly those 5 things in the soil. Now, if your soil contains too much clay, it tends to get heavily waterlogged. If it contains too much sand, by the way, it tends to be too free draining and doesn't retain enough moisture to promote good growth. So you want a good soil structure with a mixture of clay and sand. But You also need a decent amount of organic matter or humus in that soil. You can promote that by adding natural fertilizers to the soil as well, manure or compost. And a lack of humus also means that soils can become waterlogged. Now, but you're often stuck with the soil that you've got. How can you improve the drainage of it, which is what farmers want to do? Well, one way is to sort of just grow your crops on slightly raised beds like these, and which allow water to drain out to the side. That's before the seeds are planted. This is an example of what it looks like when the crops are going. That can help to promote drainage. It can build in drainage ditches, etc. So farmers need to ensure their soil is well drained, because just to emphasise, if you've got waterlogged soils like that, you will get a lack of nitrification. But not only that, you actually get increased rate of denitrification, that conversion of nitrates back to a nitrogen gas in the air by denitrifying bacteria occurs most rapidly in waterlogged soils. So if you've got waterlogged soils, not only do you get a lack of nitrification, you also get an increased amount of denitrification. What else can farmers do to help promote soil fertility? Well, one thing they can do is grow legumes. You've seen this briefly on the video. Legumes, plants such as peas, soybeans, beans, clover, contain these little root nodules containing rhizobium or nitrogen fixing bacteria. Now, not only does that mean that things like peas and beans and soybeans are great to grow, because you don't have to ensure they've got a good supply of nitrate from the soil. They can get their nitrate provided for them by the bacteria in the root nodules. But also, often farmers, will grow these plants and then plough them back into the soil at the end of the season. They might harvest the useful crop if it's peas, beans, soybeans, etc. If they're sometimes, especially in the olden days when farmers used to practice crop rotation, they would grow clover in their fields 1 year out of 4, of no use in terms of yielding any useful harvest, but they would plough that clover back into the fields at the end of the year. Or you can just plough the sort of remaining plants out once you've yielded the useful part of the crop, the peas, beans, etc. If you plough those back into the soil, then all that nitrate stored in the root nodules gets released into the soil. So that's another thing that farmers can do to promote good soil fertility. Grow crops in rotation and grow legumes 1 year out of 4 and then plough them back in. Now, we said earlier, this nitrogen cycle works really well in natural conditions, doesn't work quite so well once mankind starts impacting on it. Now, the main way that we actually have an impact, of course, is this. We break this link here. Nitrogen from producers, in other words, plants, being allowed to be returned to the soil when those plants die and decompose. Wait a minute, well, why do we do that? You might be thinking, how do we do that? Well, let me show you how. This is how. When we grow many crops, we don't let those plants die in that spot and then decompose on that same field and have their nitrate returned to the soil. No, we remove the crops, and therefore the nitrogen that those plants took up does not get returned to the soil, and those soils become depleted in nitrates therefore. What do we do about that? Well, we have to add fertilizers, of course. Now, when it comes to adding fertilizers, you've got two choices. You can either use natural fertilizers such as compost, which is basically just formed from the remains of plants, or you can use manure. Now, Both of those are very good at adding nitrate to the soil and, as I said earlier, improving soil structure, allowing it to retain a certain amount of water without becoming too dry or becoming too waterlogged. Trouble with those is there's not unlimited supplies of those, and they tend to add their nitrogen to the soil slowly. It's slowly broken down. The nitrogen in the manure and plant remains converted into ammonium, nitrate. It all takes time. That's great under natural conditions. You actually want, usually, a slow, steady release of nitrate ions into the soil. It works best for nature that way. But of course, farmers don't want that. They want a rapid increase in nitrate levels, so they add chemical fertilizers. Problems with that is it does produce higher crop yields and keeps us all fed. We have managed to just about feed a massive global population that's steadily growing, and we wouldn't have managed that without fertilizers. I fully accept, but fertilizers do have a problem. One, soil structure gets impacted upon, and two, eutrophication, which we'll come back to later. Right, just before we move on to eutrophication, look at this for a lovely sight, lovely wildflower meadow. You might think that in order to get all of that growing, there must be really rich soils below there, high in nutrients, especially nitrates. Nope, not a bit of it, quite the opposite in fact. You get wildflowers growing on poor quality soils, low in nitrates. If you've got higher, better quality soils, wildflowers always get outcompeted by grass on good quality soils, which is why you often find them growing, on poor quality soils on roadside verges, for example. A lot of councils these days actually, actively plant or spread wildflower seeds along the verges to help them. But on well fertilised fields, you've either got the crops growing that the farmers have planted there, or you've got grass growing. Sometimes people think that a well fertilised soil means high species diversity. Quite the opposite. A really well fertilised soil means the areas just get dominated by grasses, to be honest, and you get low species diversity. Right, pause my video now and just make sure you complete all the next few sections on talking about this part, factors which can affect the nitrogen cycle, why farmers need to apply fertilizers, the effect of natural and chemical fertilizers, and the effect on species diversity. Complete all of those parts. When you've done that, pause my video anyway and watch the video I sent you on eutrophication. Right, hopefully you've been a good boy or girl. Watch that video, and using that video you can now complete that final bit of the note sheet, or the final bit for now on eutrophication. Right, as I mentioned in my email, I then want you to complete sheet 1.5.6 as well. So you've done section C on the question sheet. Leave out section B for now. Then let's say one final task. A little bit of actual outdoor practical work. In fact, I'll take you out to my own back garden to illustrate what I want you to do. Right, here I am out in my back garden. Look at a patch of my lawn. A lot of clover in my lawn. Actually, as I've told you all before, I like to keep a nice diverse lawn. I don't want all these monocultures of just grass. Much better for wildlife, for the soil structure, to have a mixture of plants in your lawn. I've got a few daisies, etc. growing as well, and could do with possibly do with a mow, I know, but hope you aren't sitting there thinking, Phil's too lazy to mow his own lawn. How dare you think such a thing of me? No. One, we've had a long dry spell. Not really good for the grass to cut it during a dry spell. And two, anyway, better for the invertebrates and other wildlife to let your grass grow a bit. So no, it's not because I'm too lazy. Anyway, let's go back to the clover. Got my trowel here. I'm going to dig up just a tiny bit of the clover. Right, as I was saying, so I'm going to dig up a tiny bit of my lawn, just in the part that has a bit of clover within it. Things I do for you, digging up my own lawn. Right, okay, just a little bit like this. I'm going to tease the clover out from the grass, get its roots out of there, come back to you in a second. Right, that's what I really want you to do. Just get a bit of clover out. Sorry, it's not showing up very clearly, is it? Including a section of its root. I'm going to take this in and actually give it a quick wash off so that you can see it more clearly. Right, here we are. I've got a piece of clover that I've dug up fully and separated it out from all the grass, all its roots, given it a quick wash. You can clearly see a couple of root nodules. One there in particular, another one here. And you know, that's where those rhizobium bacteria will live, those magical bacteria that can convert nitrogen into nitrates, meaning these clover plants don't need to get the supply of nitrates from the soil. They can make it for themselves. Not that many plants can do this. Allows them to grow on poor quality soils. Also means, as I said before, can be very useful to farmers to grow this and then plough it back in to the soil. Go and bore your mum, dad, little sister, whatever, telling them about root nodules with your bit of clover. Okay, that's all for me for now. All for me for this half term. Have a good half term holiday. I know it's holiday in inverted commas compared to what we've had anyway. And contact you again after the half term break. Bye for now.